All right, we are going to be talking about 3.3, which is growth and decay of exponential functions. I'll let you do the first screen on your own. On screen number 2, today's date is, as always, today. We're going to be talking about exponential functions. This is our third lesson. Our objective is to define and use exponential functions. So this graph should look a little bit familiar. I think I've already kind of shown you this graph. The first one is growth. The second one is decay. We've got our basic formula of a times b to the x. And if b is greater than 1, it's growth. If b is between 0 and 1, it's decay. Well, they're going to make this a little bit harder because we get our first problem right here. If a function is exponential and f of 0 is 3, and remember that's just a fancy way of saying the ordered pair, and f of 2 equals 12, so my input is 2, my output is 12, then we want to find f of negative 2. Okay. Well, what's nice here is they're giving me the intercept. If that first number is 0, your second number is the intercept. So we know right away a is 3. Okay? Otherwise, it becomes a little bit more difficult to solve. And I think on all the ones that you're going to be given, that intercept is always going to be 3. So if you know the intercept, we need to know b. I'm going to go over to my other ordered pair and plug in what I know. Well, instead of using function notation, I am going to use y. So ab to the x, that's our basic equation. They're telling us an x and a y. So it's just going to be a matter of plugging that in. So 12 equals 2 times b to the x. I already made a mistake. I didn't mean to put 2 there. I meant to put 3 there. I was wondering why I was having so many 2's. Half the problem is writing it down correctly. So 12 equals a, which we know is 3, b to the 2. Divide both sides by 3. Take the square root. And we get b is 2. So now we can write our equation, f of x equals 3 times 2 to the x. And now every once in a while I'll get people who will say, well, that's just 6 to the x. You can't multiply them because they have different exponents. That exponent for the 3 is actually a 1. So they ask us to find f of negative 2. So that's going to be 3 times 2 to the negative 2. That's just 3 times 1 over 2 squared, which is 4. So 3/4. And that would be your final answer. All right, we've gotten two I'm going to give you another formula. The one that we've been using is right there. Sometimes you see a big A, sometimes you see a little a, sometimes you might see P for principal or V for value. It really doesn't matter. It's the format. It all means the same thing. This is our second formula that I want to give you. A of t equals A sub naught times b, and that is a little bit hard to see. It's the t over k, and I'll write that a little bit bigger, I think. Okay, the b is something that you are going to have to get from the word problem. If it says double, your b is 2. If it says triple, your b is 3. If it says half-life, your b is 1/2. So it's kind of the multiplying factor. And k is the time that it needs to do that. So if it doubles every 6 hours, your k is 6. If it triples every 45 seconds, your k would be 45. Okay? So on this one over here, we're just going to do the setup. There's nothing to really solve. So a financial planner has promised me that he could double my money. So right there is the key word. So that means my multiplying factor is 2, or B is going to be 2. It's going to double my money in 12 years. That means K is 12. So I want to express A of T, the amount of money after T years. So we're going to have variables in this. So the amount after T years is going to be however much money I started with, they don't tell me, times 2 T over 12. Let's see if we can make that T look a little bit better. There we go. And that would be your formula. So let's go ahead and apply that. And I'll tell you right now, this is probably going to be the most difficult problem on the notes. Because what I noticed, first of all, is they don't give me a y-intercept or a starting point. So we'll have to figure that out. They tell us that it's exponential, and we're going to have to come up with a function. Well, I look at the data, 260, 450, 780, and it's hard to see a pattern there. It really is. And I'll tell you, it took me a little bit of time to see it the first time. 260 times 3 is 780. So this is tripling every 6 hours. So that means my B is 3 because it triples, and my K is 6. So my equation is going to be A sub T equals, let's make that equals a little better, A sub naught times 3 to the T over 6. Because I can't make the T over 6 any smaller, I'm going to make that 3 a little awkward. Okay, so I need to know what A sub naught is, what my starting point is. Well, I do have data over there, so I think I can get it. And I could use any of these 3 points, but I notice, hey, I've got a 6 right there because it takes 6 hours, and my T there is 6. So I'm going to use that data point right there. And that's telling me an X and a Y. So I'm going to plug that in. And if I just notice that they're using P of T instead of A of T, it doesn't really matter. So I'm going to have 450 equals, and I'm looking for my starting amount, times 3, and they're telling me time. Time is 6. Well, 3 to the 6 over 6 is 3 to the 1, which is just 3. Divide both sides by 3, and I get my starting amount was 150. So I can write an equation of A sub T equals 150 times 3 to the T over 6. Well, that's your answer for part A. For part B, we want to determine the amount after 24 hours. Well, you're just going to take out T and put in 24. So the amount after 24 is going to be 150 times 3 to the 24 over 6. 24 over 6 is 4. 3 to the 4 is 81. So I'm going to take 81 times 150. I get 12,150. I look over there, that seems like a reasonable answer after 24 hours. I'm going to circle that. All right, the rule of 72. You may have talked about the rule of 72 in economics. It's not going to be the most accurate. It is an approximation. So if you ever want to do something really quick in your head, the rule of 72 is really a nice one to know. What it says is if you take 72 divided by whatever percent, that's how long it takes to double. Okay, so here, a bacteria colony increases by 8% per day. How long will it take for the having a hard time reading today. How long will it take for the colony to double? Well, 72 divided by 8, and keep it as a percent. So 9. It's going to double every 9 days. And it's not exact, but it's pretty close. All right, growth or decay? This one is decay because it's going down. This one is growth because the 3 is bigger than 1. On this one, it's going down by 2, 2, 4. But you look over here, I'm going to think it's linear. Because if I did the ratio of y over x, I'm also going to get, or the difference of y's over the difference of x's, it's going to be the same amount each time. This one, it's going to be growth, because that's greater than 1. Here, I'm dividing by 4 each time. My x's are pretty consistent, and it's going down, so it's decay. Not even going to talk about that one. Well, I'm going to go with growth. Well, 3/5, that's less than 1. That's going to be decay. All right, card sort. I'm going to let you guys kind of do this one on your own. What I would do, though, is you're going to have 3 piles. I would put the equations up at the top. And then you have to match up the graph. And if you look over here, I have 0 out of 9 correct. You can check it. All right, my absolute favorite. We have some marble slides. And we're going to be putting them in the form of y equals ab to the x. Oops. Try that again. There we go. I'm not going to put any sliders, but because we can figure out things really easily here. Well, A is our y-intercept. That first number here is a 0, so that's going to be a 2. And then, looks like I'm tripling. 2 times 3 is 6. 3 times 6 is 18. 18 times 3 is 54. So my B should be a 3. And I want to make sure that I still have a times in between them. Let's go ahead and launch that. And I am good. Let's do the next one. So on this one, my y-intercept is 12. It's going to be times. And looks like on this one, I'm multiplying by 1/2. And then I need my exponent. Cap lock's on. Let's go ahead and hit launch. So look and find out what that y-intercept is. If the first number is 0, your second number is a y-intercept, and then what your multiplying factor is. I'm going to let you guys do the next couple on your own. And I meant to cut these ones out, but if you want to, go ahead and do them. Just figure out what that multiplying factor is. And I think on this one it's like 1.4. So if you took 71.6 times 1.4, 10180.24. Yep, it'll give you a little hand clap. So you just have to figure out what's being multiplied. So it's 2650 times what gives you 3710. All right. On this one, looks like you're dividing by 10 each time, so I can do that one in my head. So what is the B? 1/10. All right, go ahead. Tell me how you feel. Put in a question that you have. Enjoy.